I'm Adam Hendel. I'm a founding engineer and extension developer at Tembo. And today we're going to talk about Tembo's vector database and PG Vectorize and some other extensions that we use to build Tembo's vector database. So to start, we have a sample data set. There's a table called products. We just look at that table. Every record in this table has a product ID, there's a product name, and the description. And we want to use vector search or semantic search on this because we want to search the meaning behind our user's query and match that to rows in the table as opposed to just doing keyword search. So I've already provisioned this vector DB on Tembo. And to get this started, there's just a single function that we call. And this extension is called vectorize. There's a function in this extension called table. And we give it a job name. I'm just going to call it product search HF for Hugging Face, because the transformer that we're going to use is going to come from Hugging Face. We pointed at a table, in this case, the products table, specify the primary key, and then we can pass in any number of columns to this function. And these are the columns that end up getting transformed into embeddings. And like I said, we're going to use this transformer model from Hugging Face. And for schedule, this is going to determine when and how often embeddings get updated. So since we called this function, we automatically are going to generate embeddings for all the records in the table. But if we update records or add new records, real time means that there will be a trigger will fire and embeddings will be automatically updated. Alternatively, we could put a cron-like syntax in here for schedule, and that would, for example, every hour check for new or changed records and then update embeddings that way. So one of the first things that PG Vectorize does for us is creates a view. And if we look, let's change this view a little bit here. The project creates this view called product search HF in our case, because it's the name of the project that we set up. And it's a view over the embeddings that got generated and our source table. So we have basically a join here between our source table and the embeddings. So we can see this first record, laptop stand, the description, elevated platform for laptops, and then the embeddings for that. But if we look back at our source table, you can see that the embeddings aren't here. They're in a separate table. But we have a view automatically set up to join these. Now to search, it's just one more function call, vectorize search. So we specify the job name that we used previously, and then a raw text query, and the columns that we actually want to return from our search. So this doesn't return the embeddings, this returns the columns from the source table. And when we call that, what happens under the hood is our Postgres extension handles transforming our query into embeddings, and then does the similarity search and returns the most, in this case, the top 3 most relevant records based off the similarity score. So what we just walked through right here was we had a table. We didn't have any embeddings. We called one function to generate the embeddings for that table, and then we used another function to search that table. Using vector search. Inevitably, new data will come into our source table. So, and since at the beginning, we specified that the schedule was real time. So if we go back to what we called here, we said schedule real time. If we insert any records to this table, we'll automatically get embeddings generated for any new records that come in. So if we insert a record, we'll give it a product ID 1, 2, 3, 4, 5. It'll be called pizza with a description. Now in the background, embeddings are getting generated and added to our embeddings table. And now if we search, this time we'll search for international food items. And now we can see pizza shows up as the top score. Okay, so that was like adding a new record to the table, but the same thing works on updates. So let's take a record that already exists. We'll take the hammock, and we're going to change the product name to Schnitzel. You know, it's kind of unrealistic, but for demonstration purposes here, we'll change a product from hammock to Schnitzel. So when we ran this update right now, that triggered another embedding update in the background. And now if we search again, we can do that same search that we used before. Now we can see Schnitzel is showing up and pizza. So that's generating embeddings from the initialization of a table, updating embeddings when new records come in, updating embeddings when existing records change. But this whole flow, the API of vectorized table, vectorized search, sometimes that's not quite flexible enough for you. But there is another function to just directly transform embeddings and return the embeddings to you. So you can pass in as input any text, and then pass in any model here that's available on Hugging Face. And we call that, we can see here, we get the embeddings back. So that is everything with the vector DB. There's the high level API to make it really simple to just get started with vector search. But if you have something more complex that you're doing, you can use the encode functions directly to transform embeddings. And everything I walked through here is available in our Getting Started guide for the vector DB, and the link is right there. Check it out.